Hello everyone, this is Dr. Smith. In this video I would like to go over an algorithm that can be used to take an ERD diagram or an ER diagram and from it design a relational schema. So a quick review. Here we have an ERD. We have two entities and a relationship. The entities are recognized by the rectangular form, and the relationship is recognized by the line that connects them. And the name of the relationship in this example is assigned. An employee is assigned to a project, and a project is assigned to an employee. But really, if we look at the constraints on this, we see that an employee is assigned or may not be assigned to one or more projects, and a project may or may not have any employees assigned to it, but if it does, it can have more than one. So here are the steps that we would follow. This is an algorithm that is in N-ary's textbook. You might find variations of this algorithm on the web. And what we do is we take a step-by-step approach in analyzing our ERD or entity relationship model. What we do is identify entities, the different types, strong and weak, and we identify the different types of relationships. And according to what we identify, then we either create a relation or we modify a relation that's already been created from a previous step. So when we do go through an ER diagram, we will need to identify some of these characteristics that are listed here. And if any of these characteristics are new to you, you might want to review these concepts before going further. So the first step of this algorithm states that what you're going to do is create a relation for every strong or regular entity in the diagram, and some authors call these entity relations. Once we create a relation for each entity, we're going to include all the attributes of the entity, and we're going to choose a primary key, and we're going to keep any candidate keys if we have a choice of primary keys. So in the diagram illustrated here, we have two entities. There's strong entities, they're regular entities, so we create two relations. We indicate the primary key, and that's it. That's it. Well, we keep the attributes too associated with the entities. Now here's a different ERD. Here's an ER diagram that only has one entity. And I wanted to indicate that according to step one, we create a relation for the entity, and we indicate the primary key as we did here, and we indicate all the attributes. And I wanted to mention that in this particular example, we have a multivariate attribute called members, which I included in the relation, and I indicated it was a multivalued attribute. And I did that by putting the braces around members. Members is our multivariate attribute. In the ERD, it's indicated with that double oval. And at this point, we know that this cannot be implemented in a relational database, a strict relational database, because we're not allowed to have multivariate attributes. But the algorithm will address that later. Right? Now, in step two, what we do in an ERD, we identify all weak entities. And in this diagram, we have a weak entity called budget, that its existence depends on a project. You can't have a budget unless there's a project associated with it in this example. And what we did is see that the project relation was created in step one. The budget relation was created in step 2, and in step 2, part of the process for a weak entity is that for the relation associated with the weak entity, in this case budget, we want to add a foreign key. And the foreign key, in this case, is project number, and it references the project number of the primary key in project. So that's pretty straightforward. Let's see, step 3, and we're going to look in our ERD, locate any one-to-one relationships, or binary one-to-one relationships, and we're going to decide which of 3 choices or approaches that we're going to take to resolve or convert this relationship to a component of a relational diagram or relational database, or a relational schema for that matter. Okay, so here's the first approach, the foreign key approach. So in this diagram, you can see that we have a one-to-one relationship between employee and spouse. And an employee can only have one spouse, or it may not, an employee may not have a spouse, whereas a spouse has to be associated with an employee, and it can only be the spouse of one employee. And so what we do is we recognize that in this example, employee was a strong entity, spouse was a weak entity, so they were created in steps 1 and 2. And in this case, spouse has a partial key or a primary key, either way here. And in any event, we are going to add the employee number to the relation spouse so that we create a composite key. So in this case, we have 2 attributes that make up the primary key. So the spouse ID could be a primary key, or it could be what's known as a partial key. That just means that the spouse ID doesn't necessarily have to identify each spouse, one spouse from another spouse associated with an employee. But in combination with the employee number, it will. There we go. So here we have what's known as the merge relation approach. And in this case, let's suppose we have a one-to-one relationship, as we have here, project and budget. And in steps 1, we created, let's say, the project entity. In step 2, we may have created this weak entity called budget. But having recognized that there is this one-to-one relationship between project and budget, we can decide then that instead of having 2 entities or relations, we can just merge all the attributes from both entities into one. And we only do this, however, when there is what is known as a total participation constraint on both sides of the relationship. So in this case, for example, a project cannot exist without a budget. A budget cannot exist without a project. So this merged approach is very appropriate. So what I do is create one relation called project and just put all the attributes in there from both entities. Here's another example. Here we have an example, same example, but in this case we're going to use what's known as a cross-reference or relation approach. So we have, again, our one-to-one relationship between the 2 entities, So we create a project entity in step 1, a budget entity in step 2, because it's a week. Did I say entity? A project relation in step 1 and a budget relation in step 2. And now to resolve this one-to-one relationship, we create a third relation, and we place in that relation, in this case I call it project budget, the primary keys of the two entities. So, going on to step 4, and in step 4, we are asked to identify a 1-to-N relationship. So we have titles are given to one or none or one or more employees. Clearly a 1-to-N relationship. And what you're asked to do here is for, we have two options, sorry. We have a foreign key approach and we have a cross-reference or relationship relation approach. So let's do each one so we can see. Here's the example, one-to-many relationship. So we do a foreign key approach. That means from step 1 we had the two entities, correct? They got converted into relations, and what we're going to do is add the foreign key to the many side. In this case, here's the many side. Let's see, I guess where did I add the foreign key? Let's see. Up here it is, title. So every employee has a title, and that title is a foreign key on the many side that references the primary key in the title relation. Okay. And here is another way to resolve that one-to-many relationship. Again, we created the two entities from step 1 because we have strong entities here. And in this case, we create a third relation. I call it title employee. And in that relation, we just add the primary keys of the two entities involved in the relationship. Okay. Step 5. In step 5, we are mapping M to N, or many to many relationships. And the way to do this is to create what's known as a lookup table. That's one way to call it. So again, in steps 1, we would have created the employee and the project relations. And when we got to step 5, we would recognize this as a many to relationship. And when we have a many to many relationship, I see the name of my relation is in the wrong place. It should be on top, and this arrow should be pointing to ENO. Why? Because we created a new relation called the lookup table, say, and in that new relation we put in the primary keys of the two relations that are participating in this many to many relationship. Step 6 is where we now address any multi-valued attributes. So, if we had created the project relation in step 1, then we had that multi-valued attribute called members. So we're going to get rid of the multi-value attribute and instead create a new relation. And in that relation, we're going to add a foreign key that points back to the relation. Here's P&O, or project number. And we're going to add a primary key. And the primary key would be the corresponding attribute that actually characterizes a member. So whether it was a member name or a member number, I could have just written member here, member, to have it easily identify the name of the attribute that was in the ERD. And step 7, we have a tertiary relationship here. So it's not N, but 3. And what we do here is we add a new relation to get rid of this relationship and add foreign keys. So again, in step 1, we would have identified the strong entities: employee, project, and location. And in this step, we would create a new relation, let's call it assignment, and the attributes of assignment are the primary keys of the entities participating in the relationship. And that concludes this video. Thank you.